All right, everyone. We are live, so let's get started. Before I introduce our next speaker, just want to make a quick reminder to check out our sponsored booth, which you can navigate to by clicking the booth button to your left. Once you're there, click into any of the booths to learn more and enter for a chance to win some pretty cool swag, including a custom pair of Nikes. Now, without further ado, it is my pleasure to introduce our next speaker, Alon Halevi. Alon has been a director at Meta AI since 2019, where he works on human value alignment and on the combination of neural and symbolic techniques for data management. Prior to Meta, Alon was the CEO of Megagon Labs and led the structured data research group at Google Research, where the team developed web tables and Google Fusion tables. He was also a professor at the University of Washington, where he founded the database group, and he is the founder of two startups, Nimble Technology and Transformic Inc. He received his PhD in computer science from Stanford and has co-authored two books, The Infinite Emotions of Coffee and Principles of Data Integration. He is a fellow of the ACM and a recipient of the PCASE Award and Sloan Fellowship. Alon will be giving us a talk on obtaining answers from social media data. Please give a warm welcome chat to Alon Halevi.
Thank you. Let me put this on. Can everybody hear me and see me okay?
Everything's crystal clear.
Okay, great. So thank you for the introduction. This talk will be more on the data side of AI because data is what powers everything. And this is the first talk that I'm giving ever with the company named Meta. So it's very exciting. I've got a bunch of collaborators on this work. James Thorne, who just finished his PhD at the University of Cambridge, Majid and Marzieh, and Sebastian from Meta AI, and Fabrizio, who used to be at Meta AI, but is now a professor, is now a professor at Sapienza University in Rome. So here's what I'm going to try to cover today. One is, first of all, what is the data that we're looking at? What are the questions we're trying to answer from it, and what are the applications that we're trying to support with that? When we do that, I believe that we start seeing a spectrum of approaches to answering questions from data. And what I'm going to try to hint at is that maybe we need something slightly different than what we have today. And neural databases, which is the last part of the talk, and the main part of the talk, will be about trying to go towards that new approach to answering questions from social media data. So to be very clear, here are the kinds of use cases that we're looking at. And we'll dive into the data and the actual queries in a moment. So one is what is called integrity, okay? How do we detect posts on social media that shouldn't be there? So every company that runs any kind of social media app has a set of policies that they put in place, and you can't post stuff that violates these policies. So first kind of question is, does this post violate one of our policies? That's one. The second application is more on the positive side, which is, heck, I have so many friends on social media. They're all writing stuff. Can I actually get something useful when I really, really need it? And I'll give you examples of that in a minute. And then the third kind of application, again, first talk about metaverse, is when we're going to, and this on the right here is just an image I found on the web with Mark, which is when we're going to be in the metaverse and interacting with all these agents that are going to give us all kinds of services, whether we're with our glasses or our VR, we're going to be carrying with us a lot of information, personal information about ourselves, and we're going to be sharing that in a hopefully very, very natural way. And so in order to do that, we're going to have to query that information in order to figure out which slice of information we're giving to this particular agent we're talking to at a given point. Now, the data is not what you would put in a database system, okay? So we don't have a schema. It's not like we can design the schema for all this data and and have rows and columns like we love in databases. This is stuff that is generated by users, which means it's about everything. You can't even imagine a schema for this kind of data. It is not just text, it's not just structured data. In fact, it's usually not. It's multimodal. It's text with images, with videos, with audio, stuff like that. So that's got to take into consideration from the beginning. The other thing about it is that it doesn't usually, when you take it out of context, you won't be able to understand it. So the context in which the data is posted is really important. Who it is, what time of what just happened maybe in the world or in their lives really matters. And the life of a post is not very long either. So that's why you don't actually see a lot of posts from last week, because they're just like nobody cares about last week's news. The other thing is that it's very subjective. So in databases and in general, when we look at knowledge, we like to think that there are objective truths about the world, and we're always trying to model these objective truths and get to them with the queries that we ask. And we always assume there is, even if our data is dirty, we always assume there is a truth somewhere, and we just need to work harder to clean up our data or fill in missing values or stuff like that. That is very, very different in social media, because there is no ground truth. It's people opining about the world. It is people expressing their experiences that they're having. This is not objective anyway, in any way. So basically what I'm trying to say is this is really, really complicated data. It often comes in the form of a social media post, which can contain multi-modalities. And sometimes, if we're talking about personal information or information that I want to remember about what I interacted with, it might come as short textual facts. Okay, so we're not talking about paragraphs of people pontificating about the beauty of the world, but it's more like, Mark was born in the US and has lived there all his life. I may want to remember that after I talk to Mark, so maybe it'll be helpful to me when I talk to him next time. What are the questions that we want to answer from this data? So this goes back to the use cases we were talking about. So one is we want to know whether this data is violating. So for example, is this post hate speech? And in order for it to be hate speech, we need to be able to verify that there is some sort of attack, like a demonization of some group, of a protected group that is shown in this post. So this is a very common type of violation. Another, which has received a lot of press, obviously, is misinformation. For example, I want to find posts that say that X won the election, okay, or that X or Y is a cure for COVID. So I want to be able to find these things rather than just being very reactive about them. The area of integrity is a very rich one, and we wrote a survey on it that you're welcome to see on arXiv already, exactly kind of the authors that you saw before. Or if you're very patient, you can wait for February of next year. A short version will appear in the communications of the ACM. So that's one kind of question. Another kind of question is, I'm going to London, or I'm planning a trip to Costa Rica. Which of my friends lives in London? Or which of my friends have gone to Costa Rica recently, and what have they posted from there? So this is more information that is buried somewhere in my feeds, but now that I have a clear intention of either visiting London or planning a trip to Costa Rica, I'd like to find that and make use of that information. Another kind of question I want to ask is, I'm sitting in a restaurant and I'm wearing these fancy, these fancy AR glasses that are supposed to help me make decisions about life. What did I order here? What last time? And what did I think about it? Okay, so maybe that will give me some advice about what I should or should not order on this menu today. So what do we do today about these questions? Well, for the case of hate speech, what we do is we build a model. We build a machine learning model based on a lot of annotated data. This model is very multimodal, and we make predictions about whether a new post is misinformation or not. Hate speech or not. With misinformation, the problem is a little more complicated because we, for example, as Meta, we should not be the arbiters of truth in the world. So Meta should not be deciding whether something is a cure for COVID or not. So what we do for misinformation is we actually take the suspected posts and give them to third-party fact checkers that come from all the way into the political spectrum, and they are actually trained in misinformation and in medicine or whatever it is that is relevant, and they make decisions. Now, what we do is we try to leverage their previous decisions. So if we have a post that was deemed to be misinformation before, we find something that is very, very similar to it, then we will automatically decide that something is again misinformation. So those are the approaches that we have in the integrity world. And when we get to like, who are my friends who live in London or visited Costa Rica, the technology we have is natural language QA. Okay, so there have been techniques, and you're going to see this in a moment, that can take a passage of text and answer a question about it, and they've been making a lot of progress in recent years. So if you look at these methodologies, right, when you build a machine learning model to answer a question, you're sort of at one end of the spectrum where you're saying, look, I'm going to ask the same question again and again. So that means I can invest a lot in creating a model that will answer this question. It's sort of like if you know anything about databases, it's like materializing a view. You know that you're going to ask a question a lot, so you're going to just pre-compute the answers, and somehow you'll handle updates to the data in a secondary mechanism. So that's one end of the spectrum. On the other end of the spectrum, what you do is you do information extraction. You take all the data that you build some sort of schema or some sort of knowledge graph about the world, and you try to extract data into that knowledge graph. And then once you've extracted stuff into that knowledge graph, you can ask anything you want. You can ask any kind of query you want about the terms and the objects in the knowledge graph. And so that gives you query flexibility. Of course, the problem is you're limited by the schema of the knowledge graph and the accuracy of your extraction, but you have more flexibility on the queries. Now, there are a bunch of approaches in the middle, like zero-shot or few-shot learning, where you don't have to invest so much in building a model or adapting a model to a new question. There is also work on common sense knowledge graphs that are not as precise and formalized as traditional knowledge graphs, and they are actually producing all kinds of interesting results as well. One thing that is really interesting to point out here is that when a question is decomposable, in other words, you can take that question, like, for example, hate speech, right? So for hate speech, you need to find an attack vector, and you need to find a protected group. Okay, so that's decomposable. Or if I'm asking, which of my friends has gone to Costa Rica in the last year, well, I can decompose it to the usual database building blocks. So when you can decompose, when you don't decompose, then you build a model, because you don't actually know what's going on in there. And so just treating it as a one-shot question, that's the right thing to do. But when you can decompose a question into a few sub-questions, then you're getting more towards the right-hand side of the spectrum, where you do want to extract the information into multiple, maybe a structure, and then answer things from the structure. So that's interesting. But so when you decompose a query, it means you decompose it into some subqueries, and then you put the answers of the subqueries together using a bunch of operators like AND or aggregating or something like that. Now, the problem with decomposability is usually you decompose with respect to a particular schema, right? So you have a question, and now you have some building blocks, which are the parts of your schema, and then you can decompose. Okay, I'll find this relation, I'll find that relation, and then I'll do a join or something like that. But we don't have a schema here, so there is an intuition that says we want to decompose, but we have to figure out a way to decompose without a schema. The other thing that is important about decomposability is that if you actually want to explain your answer to somebody, which is something that we see a more and more of a requirement to do, then being able to decompose it to different parts and explain how you got to the answer is really, really important. So, this is another reason to think about decomposability when we answer questions from this kind of data. So neural databases are going to be a methodology in which we take the decomposability more seriously and try to answer questions by answering sub-questions. There have been other attempts to do this, like neural module networks from Berkeley a few years ago, and a bunch of work that followed up on that. And you can think of some of the, I call them funky neural knowledge graphs, because they're not the knowledge graphs of old. They're cool. They're neural. You don't exactly know what's there, but they're very useful. So that's another approach that I'm not going to talk about, but I think is really, really promising. So now let me turn to talk about neural databases. So neural databases can be thought of for answering queries over text or text and images. Right now, what we've built and what we've experimented with has only to do with text. And so the database here is a database of short sentences in natural language, like John lives in Canada with his brother, Bob moved to New Mexico in December last year. These are the kinds of facts that we're going to take in this database. And the query also is expressed in natural language, like how many people live in the US, who lives in North America. So so notice here that there's no schema whatsoever. We're just writing stuff down, and we're writing down questions, and we expect awesome things to happen. Now you could ask, well, why can't we just do this all with databases? And I sort of alluded to the answer already before. Databases are great. They scale up. You can ask very, very complicated questions, but the schema is determined in advance. So when you design a database system or database application, you need to figure out what it is you're going to say. Okay, and anything that doesn't fit in the schema is going to be lost. You're never going to be able to query it again. It is possible to change the schema, but not at the rate that you're going to need in order to support these kinds of applications that we're talking about. And so not only that, people forget the schema. The schema is for good reasons. The schema has a lot of design principles that when a layperson goes and asks a question, they will not be able to figure out how to answer that using the schema. So the schema is a very critical bottleneck in the design of database systems, and for the kinds of applications we're talking about, they are not appropriate. Now, that being said, I'm not trying to sell neural databases as a way of running your bank database or even your university grade system. Okay. So the question is, can we even reimagine database systems without a schema? And the reason we're doing this is because the natural language processing technology and vision technology have gotten to the point where, darn, that might be possible. So let's so with state-of-the-art natural language processing models, we can do things like the following. We can take a set of facts, like Sarah married John, and John works at Shell, and Sarah is a doctor, and or Sarah is from France, and actually ask and take a query. All these things are written in natural language. Okay, no schema, no nothing. Take a query like who is French, and feed all that stuff into a transformer, and actually get an answer. And that's kind of mind-blowing if you think about it. I'm a database guy, so my mind is blown. But that gives us a hint that maybe there's a possibility here of actually scaling this up into more complicated queries over larger amounts of data. And so this is a huge, I'm sure you all know this, there's a huge line of research in natural language processing today, and it's called question answering. And what is done is, you take all of Wikipedia, you get a query, and there's some module that first of all finds a very small number of paragraphs in Wikipedia that might be relevant. Of course, if you get that wrong, you're not going to recover from that. And then what's left is fed into some sort of transformer-based model, and interesting answers, often very, very correct, come out. So the question is, well, how do we take that basic goodness and scale it up to database queries? So what we did was we started by doing an experiment. We took a transformer module a T5 transformer, and we fed it. We fed it the facts. We were dealing with tiny databases of 50 facts. We fed it the facts. We fed it the query, and we experimented with a bunch of variations and with a bunch of query types. So one query type is just like, who lives in Florida? That's just give me the answer from here. Another query type might be a join, where you actually have to take 2 sentences and figure out the answer from the join of those 2 sentences. And a third query type is set. So who are the children of Mark? They might have 5 children. So the answer is not one thing; it's a set. And then there is min-max queries. So like, who is the youngest person in the database? Here you have to look at the age of everybody and figure out who is the youngest one. Basically, what we found was that you can see that the bars. I'm not going to go into detail of this graph, but you can see that the bars are pretty high. The answers are we get extremely high accuracy for things like atomic queries, and even join queries do quite well. Where we don't do well is, so this is just to be clear, this is taking current state-of-the-art NLP technology and trying to use it for database queries on tiny databases. Where it fails is on sets where there are multiple answers to your query, and things that require some sort of basic mathematical reasoning, like min, max, or average. So, well, that was good, because at least there's a core of something good. But now how do we get from there to answering queries over larger amounts of data? So the challenges here are that the encoders of these transformers are limited in the size of the input they can take. So okay, we all know that. Another part is like, what do you feed to these transformers, right? You need to sort of figure out you need to make sure that they get all the relevant facts so they can do their magic. But if they don't get the right facts to start with, then you're out of luck. It doesn't matter how smart your transformer is, and transformers will often hallucinate, but that's not what you want them to do. So here's the basic difference between database query processing and what's been done in natural language processing for question answering. In the database world, and I'm showing here an example, find Turing Award winners that are over 60, okay? In the database world, the notion of a set is very fundamental, okay? What a database thing would do, it would say, okay, let me find all the Turing Award winners, let me find all the French people, let me find the intersection of those. And of course, on a database, databases know how to do this extremely efficiently, because they will realize that the number of Turing Award winners is tiny, and the number of French nationals is huge, so they do the right thing. So then they will do a join, and then they will filter over, for the age. But the basic way of operating is that you operate on sets and apply operations to these sets, and that core idea doesn't actually happen to the best of my knowledge, in NLP question answering. So here's the important slide to look at for neural databases. Okay, so I should say neural database is sort of a concept for any kind of database system that tries to incorporate these ideas. We actually built a neural DB, which is an instantiation of this architecture, and you can get the code and a data set that I'll talk about in a moment. So the conclusion is pretty simple, actually. If you think about it, the transformer knows how to do the magical stuff. Okay, it knows how to actually extract the answers from short sentences given in natural language. So the trick is two things. One is, what you're going to do is you're going to run a whole bunch of transformers in parallel. Okay, each one will get a small set of facts. We're going to call them support sets. And if you do this right, then every transformer will get enough of a support set so it can generate the beginning of a real answer. Okay, so we're going to take the database, we're going to split it up into these small, possibly overlapping sets. Each small set will be fed into what we call this neural SPJ. SPJ stands for select, project, join. That's like the basic operators that a database does. Okay, and what will come out of there will be the beginning of an answer. So let's take an example. So we have this database of facts about John and Sarah and stuff like that. And so we're going to take a support set saying Sarah is married to John. John works at Shell. Okay, our query is how many people's spouses are doctors. Okay, so the neural SPJ will come out of there saying, I see nothing relevant here. Okay, in the second support set, I'm going to have Sarah as a doctor and Sarah is married to John. Okay, notice that Sarah is married to John is actually in both support sets, and what you're going to get is the answer is John. Okay, now imagine you have a database like that with all kinds of Sarahs and all kinds of Johns and all kinds of doctors, right? And so what we're going to do is we're going to feed. So we're going to get John, we're going to marry, and we're going to get all kinds of people whose spouses are married, whose spouses are doctors. And then the aggregation step, which is how many people spouses are doctors, that we're going to do the good old way like we would do in a database. So we'll just count the number of answers. So essentially what we're doing is we're using the transformer to generate the first bit of a structured answer, okay? And then we're feeding the rest into a more traditional database engine. But the beauty of this is that the hard part, which is the getting the John out of these two sentences in English, is done using neural technique, which means that you can actually write it. You can write these sentences almost any other way you want, and even in another language. So this is the core architecture of a neural database. So then there are two questions, right? One is support set generation. How do you take a big database and splinter it up into these small support sets that you can feed to the transformer and everything will work out right? And the answer is that I don't know the answer yet. There's more research to be done here. But if you look at the natural semantics of many applications, you already get very obvious support sets. So if you look at posts on social media, well, every post is a support set. Okay, you're rarely doing a join across multiple posts. If you're looking at personal information of a particular user, well, even that, if you start sharding it by user, then you're already getting down to a smaller size of a support set that you can now think of maybe break down even further for support sets. But there's the applications already sort of tell you how these support sets can be constructed. But the one beautiful thing about the database community, or many beautiful things about the database community, is we know how to do indexing like nobody else. So there's an opportunity here of actually looking at data and finding ways of intelligently indexing it in such a way that when you get a query, you get the support sets coming out with pretty good guarantees. But yet, it's an area of research. The other thing that you need to do is train this neural SPJ. Okay, so the problem here is, right, it knows how to answer questions about spouses and doctors because it's seen training examples, right? So you need to figure out that, so you need to train your system to recognize or to understand how people speak in language about different relations that you're interested in. And there's a question here of, you know, how much transfer learning can you do? So if I trained it to understand spouses and doctors and family relationships, can I now go talk about other professions and maybe more extended family relationships? And the initial evidence that we have is, yeah, kind of. There is the ways people talk about things in language when they talk about factual information doesn't vary that much from one relation to another. But again, this is one of the interesting research challenges. It would be beautiful if you could just like get a neural database that just knows so much about relations that people ask about in English and just like do the right thing without even have to provide any training data. The other thing that we did under the covers here is translate an aggregation query to a to the pieces of it. So if I'm asking you which place has the highest yearly number of visitors, okay, say the Ibaraki Prefecture Museum History has a visitor count of 93,000. Great. So what you really need to do is you need to take that, that's called an aggregation query because you're asking who has the highest number, right? So you need to take that query and translate it into a subquery that says, for every tourist attraction, how many people visit it per year, okay? And so that's what you're actually going to give the neural SPJ to do, and then you're going to figure out the max after the neural SPJ gets the number of visitors for every venue. But you need to translate that query. You need to understand that if I'm asked about the maximum number of visitors, then I need to actually pose a different query, which is how many visitors came to every place, and that's not terribly hard. We actually we created a data set called Wiki NLDB that is available for download that enables you to try building better neural databases. We basically, the challenge there was, how do you generate a data set where you actually know the answers, right? So you need to start with some sort of structured data, and then you find text that says the same thing as in the structured data. You line them up, and then you get you can build a data set that actually enables you to do experiments. So these are databases of size 25 to 1,000 facts, using a whole bunch of templates of queries and templates of how people say stuff. And so you can, I'll give you a link in a minute. I'm not going to go into the experiments too much, but what you're seeing here is that the architecture, the idea of actually splitting the data up into multiple transformers and then aggregating the results does scale at least to 1,000 data facts. Okay, but that, you know, that is sort of a proof of concept that this thing can work. This is a link to some of the code in the data. You can see this. You can probably Google this by now. If you want to hear more, read more details, there's a paper in VLDB this year and another one in ACL. The ACL paper focuses on the data set. The VLDB paper focuses on sort of how are we going to build these things and what are the challenges going forward. So I actually want to talk about the challenges for 1 second. So we always want to, you know, in databases, we always try to answer more and more complicated queries. And in databases, we also have this thing called semantics, right? So, you know, when you deal with numbers, there are certain things that you know that 15 is greater than 12. When you're trying to push everything into a neural model, you're not going to get that in a reliable fashion the way you would from a traditional database query processor. There's another thing, which is when I put a new fact in a database, in some cases, it will make a previous fact incorrect. So for example, if I told you now that I work for Meta, and tomorrow I came and I told you that I work for Google, well, I can't work for Meta and for Google at the same time. So you need to understand that it's that you should be deleting the previous fact. But if I told you today that I like coffee and tomorrow I tell you that I like tea, well, I still like coffee and I like tea. So how do we understand which facts can live together versus ones that don't? There's hope that NLP technology can help us with that. Obviously, when you're going to deal with these big language models, you want to make sure that you don't introduce biases into your answers. Okay, and this is another exciting area of research. The other interesting area is, so neural databases are great. They're sort of standalone. You can take your text and answer queries over it. But we foresee that in many practical applications, this will be part of a bigger data ecosystem where you have a lot of data that is structured the way it was before, but then you have all this data that is like doesn't fit into a schema. And so, how do you combine neural databases with existing databases in a seamless way? And that is the end of my talk. So I will take questions.
Thank you so much, Alon, for the fascinating talk. We do have 9 minutes for questions, so please type your question in the chat. I'll do my best to get to them. So to start off, we have a question about how do we resolve pronouns, meaning that when you break down the text, you might have he instead of John, and you cannot make the reference back to John.
That's a great question. And so it depends on how you collected the data. So sometimes you'll be able to infer who you're talking about. And sometimes, so what I don't foresee is that we're going to take large paragraphs and sort of break them down into sentences and then do the co-reference resolution that we need to do today. What might be more relevant is like, I'm talking to Mark, and I will want to record that, Mark said so-and-so, and then I'll say he said, something else. And so given the fact that I'm still in conversation with Mark, that will be understood just from the context that I'm in. But yeah, all the techniques that we have today for co-reference resolution will still be really important.
So I guess there is a bit of work in terms of, the data coming in is more from conversational data and very specific to kind of like how social media data is used rather than, news articles or white papers or research papers.
Exactly.
So
context is really important.
Definitely. And our next question is, are these neural databases currently used in the problem like fake news detection, or how far away do you think they are from being implemented in production?
They're not used in production yet. You could probably tell from my hand waving that this is very early stage work, and I wish we could make faster progress. I think it's interesting that you touch on fake news detection, because that's a place where we need to be more proactive, right? So we know, this is me speaking for myself, but we know the kinds of things that we see often in misinformation, right? We know that people are claiming that all kinds of weird stuff is a cure for COVID, right? So what we want to do is we want to actually ask the query, find me all the posts that say X is a cure for COVID. Okay, and that way we'll find all the wrong stuff and some right stuff, right? But right now we're very reactive. We see something that somebody claims is a cure for COVID, and we do the right thing with it, but it doesn't help us with necessarily with a different kind of claim that something cures COVID. So I think that's where when you have a database, you can actually be very intentional about the queries that you ask. So neural databases can bring that intentionality into querying this multimodal data.
I see that makes a lot of sense, and very very exciting work. And hopefully this kind of moves along with. I guess that kind of leads to the next question: is what do you see the next stage of this work would be?
I would like to see it go in a few directions. One is, first of all, it needs to be made more robust and just like work at bigger scale. Okay, that's one. The second is I'm very excited about actually combining textual data and images. So today we actually have very capable visual query answering systems, right? You can actually look at an image and say, what is the color of the bag next to the green ball on the couch? And that's a neural database right there. So how can you combine the strengths of the computer vision advances with NLP advances in the context of neural databases? That's tremendously exciting. And the other thing is, my dream is that we won't need training data. So I would like us to be able to, when you buy your neural database, and I'm not selling it, don't get me wrong. When you take it out of the box, you already have in there built-in training data for almost any relation that you will ever ask about. Okay, today we have to, you're asking about a relation about who won the elections. Well, you need to have some training data about winning elections. But why not have sort of the Wikipedia or Wikidata of training data for almost any relation? Then the value proposition of neural databases would be much higher even. That's my dream, but got to take smaller steps to get there.
Yeah, and it makes a lot of sense, kind of with the direction of what Meta is going towards, which will in the future most likely be taking kind of real-time data, both through textual, but also video, which includes like audio. There's very exciting work in terms of audio NLP without covering to text. I think Facebook AI is actually one published that paper. So yeah, very exciting work, and hopefully in the future we'll see more. So one of the questions asked more so about the current implementation with NLP. Do you filter out the information that do not necessarily have any semantics to it? For example, a sentence that has no meaning in plain English or slang.
So no, we don't. We take an existing language model and we fine tune it. One thing where we get a little luckier so far is, when we generate an answer with neural databases, those answers need to be based on the facts that we give it, right? So there's the language model sitting here, then there's the database. So as long as the answers are based on the fact, they're somehow combining the facts that are in the database, then we are less of a risk of getting any bias, right? Because you have to ground it out in facts that you actually told the system. Now that's not exactly bulletproof, right? Because I can still, who knows what the language model is doing. I might tell you that somebody is a doctor, and then you will infer from that the gender of the person in a biased way, and that will sort of join with another fact. We haven't seen that happen yet, and we haven't actually looked for it or experimented that explicitly. But the fact that we do ground everything out in facts in the database does save us a lot.
Mm-hmm. So looking at the time, it's almost 10 from the hour. I know you have another engagement, so there are a lot of questions in the chat. Is there any way for anyone to reach out to you? What's the best way of contacting you?
First of all, I'm happy to stay 5 more minutes and answer more questions. My email address, I don't know if it's on the slides, ayh@fb.com. My initials, AYH. I'm very easy to find on the web too. Just find me, and I'm happy to answer questions, especially if you want to work on neural databases.
So let me just repeat that, is ayh@fb.com.
Yeah, I don't know if meta.com works yet or not. But
Okay. We might have to switch over soon.
yeah.
So I kind of lost track in terms of questions, but I guess kind of talking about the team, what is the current size of the team, and roughly, and which is the how many people are kind of working on this solution?
So at Meta AI, we actually work across teams. So there's no single team that is focused on neural database. Just like the people that you saw in the in my first slide, and a bunch of others that have been contributing over time. Interns do a lot of the work. It's very early research, so we sort of bootstrap it from whoever's interested. And this project was, people got interested very quickly.
And our next question is, can neural language search be automated into unstructured database as bots that automatically map the facts between two or more people that give more precise verification of facts presented?
Hold it, I need to see that question. Can natural language search be automated? That is a really, really interesting question. I don't know the answer. Certainly something that is worthwhile doing research on. If you can define a task and figure out how to evaluate it, then you can make a lot of progress here.
And I guess the next question, I think if you see something, is this model that could work to train these models? If you see something, I can't quite understand the question. If you want to, Dimitri, if you want to elaborate on that question, I could definitely try and get back to it. We'll just move on to the next one. How do you want to deal with the uncertainty of answers from NeuroDB compared to the deterministic answers from traditional DB? One answer is definitely depends on the application, but any other insights?
Yeah, Stan, you stole my answer.
Not giving you the easy answer.
I think I'm hoping that over time we can develop ways for neural databases to be introspective, to know when they're getting stuff right, when they're unsure about what they see. But the same question actually applies to language models, right? Today, language models will always give you an answer. No matter what you ask, they'll give you an answer, right? Even if they have to hallucinate it. So I think the same question goes back from the neural database down to the language model as well. But again, because we are dealing with facts that are given, then I'm hoping that we can develop better ways to be retrospective about our accuracy. Or maybe there's even a way of attacking it, right? Maybe there's even a way of trying to fool it and see whether you can fool it, how robust your answer is to the data. So you add another fact. Does it change dramatically? Well, then maybe there's something going on there.
Kind of the, I guess, weight of a fact. And just thinking, you mentioned there was a other database structure that has kind of potential. For example, I think it was like the funky knowledge base or knowledge graph. Yes. I love that.
So this is that something. If you look at some of the work coming out of AI2, where they have common sense knowledge graphs, it's a big field now. So what's interesting about these knowledge graphs is that knowledge graph, you need to design the nodes. What are the nodes going to be? People, companies, locations, and the edges, right? So the edges can be lives in or whatever. So what they do there is they actually only define the semantics of the edges. Okay, so they will have something like X will feel something. So for example, they'll try to say, if X does something to Y, then how will Y feel? Now, how will Y feel is the relation. It's well defined, but what X will do and is just in a phrase in natural language. So in some sense, they're just focusing on understanding affect, but they're not actually saying these are the only things that you can do in the world, right? So that's why they're funky.
I see. I guess is that something that can be combined with your current implementation, where one area that I guess knowledge graph is good at is almost fact finding relationships and almost having that deterministic, because that relationship is represented as edges between nodes.
Right. That's an interesting question. I haven't. I mean, I think in the when you actually look at how these things are going to work, there's going to be a spectrum of information that goes from structured through funky to unstructured, right? And so you want to make sure that, for example, some of the information is my age or my location, my address. Put that in a regular database. Don't put that in a neural database, right? We know how to store and query that.
So I guess there is a lot of work in another future work, which is what you mentioned in the slide, which is being able to have neural databases work in concert with traditional databases, and even the different spectrums of new arising databases as well. Yep. I see that it's also 5 from the hour now. I just want to make sure that you make it to your meeting.
Thank you.
Sorry, everyone, everyone's question that I couldn't get to. If you have any questions, please shoot Alon a message, and hopefully you could get to it. Thank you so much for joining us today.
Thank you for having me. Thanks for the great questions.
Thank you, everyone, for joining us as well. Have a great day.